Today's video, we're working on my Dolphin pull robot. This is the Maytronics pull robot. I've got 3 motors here, and I'm going to be rebuilding them with new seals, new capacitors, because those things have gotten wet and I don't trust them, and just kind of changing everything out. So I'll show you what I bought as far as parts, and then we'll go ahead and take all this stuff apart and reassemble it with the new parts. As far as the parts go, I went ahead and bought all these on AliExpress from China. I went ahead, took the old ones out on some of them, got all the measurements, because these things actually have their measurements and their part numbers right on top of them. If you can look at them once you take it off, and you can see the numbers. All you need to get is the inner and outer diameters and order similar ones from China so you can actually fit them onto here. In addition, I picked up some capacitors. These are the same size capacitors that are on here. I actually measured the farads on them and ordered the exact same ones for that. In addition, since I'm already have all the stuff open, I actually ordered new seals for all the top right here, the trim around there, the seal there, once you put it into the actual housing. So I have all those seals. I did pick up some generic brushes for the brushes in here for the ones that are worn down. For the motors I had, I don't think the brushes were that worn, but we'll go ahead and open them up and see what's inside. So on my previous troubleshooting video, I had swapped this cap off of my motor that's actually active right now in my robot, and I discovered this right here. This looks like de-zinkification right here. What happens is the chlorine in the water actually removes the zinc from this brass. The zinc is what the brass and copper mixture is to keep it stronger than regular copper. So what it did was it basically pulled all the zinc out of it, and it started corroding, so it left behind the bare copper. Bare copper is really soft, so it was actually just breaking off here. So I actually swapped this thing off another motor I had, and what I did was I took everything out of there and just swapped it over, because the shaft on my other one got eaten up too, because of that all that copper or whatever that was breaking off got into the seal here and then wore out the shaft. So I lost my shaft here, so that kind of sucked right there. Right now I have this really early generation motor right here. This one is probably 5 or 6 years old right now, and then it was a little bit different than the newer one I took out, and you could tell the numbers and the stickers on them are different too. This is a newer generation model right here. This is an older one. They still have the same part number, but they're slightly different on the inside as far as the magnets go, the shaft length, and then just the overall diameter of this part right here, the stator, I think. So we'll go ahead and open this one up, because this one was previously bad too, and you can see my amps were much lower than the ones on the newer ones. I think the newer ones are closer to 1 amp when I'm running it. This one starts at a 0.6 and it ends up at 0.5, which means there's something wrong with the brushes or something electronically wrong with that. So the first thing we want to do on the motor that's intact right here, let me get all my junk out of the way. So you want to go ahead and take these things off. Before you actually start, you want to go ahead and mark some markings right here so you can kind of get it back together. So mine already have those markings right here, because I've taken this apart before just to clean it out or see what was inside of it. So we'll go ahead and take those things out. You want to make sure you turn this with something that's tight, so that way you don't strip out the heads. These are prone to stripping out, especially if they gotten wet. As you do that, you can see these things are pretty rough shape just because of the exposure to the chlorine. So you go ahead and just pull the cap off the top. I've already cleaned these out, but once you take these things out, you're gonna find a bunch of dust in here from all the brushes and just, you know, wear and tear. So what I usually do is go ahead and blow that out with some compressed air. So right now this thing's kind of stuck for some reason. So yeah, you want to tap those and just, it should pop out, but it's not. So I don't know, you just pull that out. So that you can pull that out, it's magnetic in there, so that's what holds it in there. There we go. Go ahead and get that out. So So you gotta watch out for that wave washer. There's a wave washer at the bottom of this thing right here that generally falls out. So in here it's a pretty basic, you know, you've got your normal brushes right here. So you wanna check, make sure those things are, you know, moving in here. The springs are working and they're not too worn. So these are not really that worn, so it's pretty good condition. I don't trust the capacitors because they've been wet, so I'm gonna go ahead and swap those out and desolder and resolder those. Other than that, I've already cleaned this thing out. As you can see, this thing was much more caked with a bunch of crap in it earlier, so I'll go ahead and do that, and we'll see if I change those things out, if I can increase that as far as the amps and everything. Right now, as far as this thing goes, I could tell that the bearing on the bottom seems like it's got a little bit more resistance, and then the top bearing too. So I'll go ahead and swap both these bearings out. Earlier what I was mentioning was the different generation. So the older ones, you could tell the cap doesn't fit because it's loose on the newer motor right there. It's a different variation. It's nice and tight, it won't go anywhere. This side, it won't go in that. So that's how you know. The other thing you know is that this thing right here, it's actually a little bit bigger, so it fits in here and it fits in here. Or this one's actually smaller, so it fits, but on this one it doesn't. It fits in there, but it doesn't fit in this one. So for the bearings and everything, if you look at them, you'll see the bearing number on here. It's basically the size of the bearing. So this one's 626 RS is the bottom one, and the top one is 608 RS. So usually that's a common standard bearing that you can just order off of Amazon, and that's what I did as far as the ones I'm gonna replace it with. So to remove the old bearings, what you gotta do is you need a bearing tool. This one I had gotten online, so if you need something like this, just go ahead and check out the links down in the description. But these are like $5–10 on Amazon, but you just need it to be able to catch in there and then be able to turn it. This one right here, it doesn't necessarily go all the way in. It's enough to get it out, so we're gonna have to tap this out on the vise just to get it all the way out. But what I do is I use this just to break it out of there, and sometimes it'll be enough just to get it loose and pull it out by hand. But this one, we're gonna have to tap it on the vise. The one on top is much easier because it's actually, this one, the head of it's small enough to get into here, and the shaft, the problem is this side narrows down, so it loses a lot of that. So I'll show you how to tap that out in a minute. If you want to adjust the side to side to make it tighter, you can, but you probably don't need to. Just need to basically just go ahead and turn it until it comes loose from the race, and it should slide out after that. And once you feel it going loose, it just comes right out. So you got the old bearing out, and then we go ahead, tap the new bearing in, and then I still need to take this one off, so I'll show you how to do it on the bench. Over here, what I did is I found these little wrenches I had. These are from all my furniture stuff that comes with it. This is enough to get it around here so I can hold it both sides, and then kind of just have it as a hanger right here. Tighten it down as much as you can. Get it in place, you want to basically tap it out, but just to make sure you don't drop anything, put a bag underneath here to catch it, and then that way you don't drop it on your feet or have another set of hands. And then that way it just falls into the bag. But what I do is just go ahead and tap it out, and it just comes right out. So one of the things I would recommend you doing while you have this thing out, basically just chuck this onto a drill, take a piece of Scotch-Brite, and then just polish these things up so that way you get it clean. As well as this part, you want to go ahead and polish all that up too, clean it all up so that way when you put the new stuff in and then you put the new seals in, you don't have any birds or anything. They say chuck it, you basically just get it so the chuck can fit into the round part. Tighten it down, just tighten it down so that way you can spin it, and then you basically just hold that around here, just spin it. I'm at him. Clean up that part, and then I'll clean up the copper too. Just enough to polish it up and get it clean. Once I'm done with that. It doesn't take much to get it cleaned up. So chuck this one right at the tip. I just go ahead and get the very end that I didn't get before. It's enough to polish it up. Next thing we do is basically just go ahead and tap the new bearing in. First you want to see if it will go in by itself. If it won't, you just basically keep it on a flat surface. I've got it right here on the vise, and just take your hammer and just go straight down right there, and it goes flush and it just stops right there. So what I did is got a washer the same size as the shaft, a little bit loose there, put it around there. Go ahead, put this on, and then that way when I tap down I don't put any pressure on that, and I just go ahead and just a couple taps down there, and it's flush. There is a stop at the bottom that stops it, so we pretty much replaced both bearings right there. So the next thing we want to do is we'll go ahead and replace the seal on here. You see on the inside of this particular version, I've got a little lock pin right there that kind of stops the thing from coming down. You can actually remove that and tap it through. On the older versions right here, like the one that got corroded, or actually there's a new version, I think, it's solid, so you actually have to get something inside there to tap the old seals out. I'm using the one that's scored right there, so I don't care. So you could actually just kind of move it. You could actually use anything actually in here, just remove it. But yeah, once you pop it off, it's just a plastic cap. So once that's off, you can see your seal in there, and this one's in bad shape right there. So what I'm going to do is I'll show you guys how to tap that thing out right now. So for this one, basically an 8mm socket fits right into that hole, and it's enough to push it out. So we have to actually again go back to the vise, tap this thing out in the vise. It's enough to grab around the outside so it doesn't really move and it doesn't go through. Put this thing right on the top and then tap it through. Both seals fall right out. Once we get it open, you can see the inside of it. Just go ahead and clean out any old corrosion, any old grease, and we'll repack it with new grease once we put the new seals in here. And the old seals right here, you can see the inside of them is just packed with old dried up grease. They're both the same size right there. It looks like a 22mm outer and a 6mm inner. I believe that's the size, but if you need any of these replacements, I'll just link them down in the description. I'll give you the actual dimensions so you can look these up. But yeah, so pretty much these things basically just rot over time from all the chlorine and everything, and then it just kills the seal and then also the little spring that holds that. So we'll go ahead and put the new one in, grease that thing up, and then tap it back in. All right, so I went ahead and cleaned everything out of here. Make sure all the races are clean on the inside, no more grease. Cleaned out any corrosion I can get around the edge. So these seals right here, they're basically 22 outer diameter, 6mm inner diameter for the shaft, and then 8mm height. So one of the things I wanted to do was test it. So you want to basically go in, seal. So this one is a much better seal than the one we took out. I can see already that this inside seal is much thicker. So hopefully this seals much better and doesn't let any moisture or water in. And then as far as getting it in here, we want to go ahead and use some Magna Lube. I use Magna Lube because that's marine grade and it's going to be water resistant, silicone based, so that's what I want to use on here. So what I want to do is get some around the inside of here so I can press it in upside down like that. So you want to make sure the face of it goes down, then pack a little bit of grease inside, and then do the same on the top. Get some around the shaft, and then make sure that it's lubed when we get the shaft in there. So once you push it in there, it goes in pretty easily once you make sure that lube's in there. I'm gonna go ahead and just pack some in here, because this thing is gonna be, over time, it's gonna have to heat up and kind of spread out inside there. So you wanna have plenty in here to work with. Again, you wanna just get enough in there so it can work. Yeah, once I press it in, it'll compress it all to the outer edges, and then just have enough in there. So we go ahead and press that in, and then we'll go ahead and pack this part before we put the cap on too. This part might be exposed to more water than that bottom part, so that was why up here this grease will probably dry out and basically wash out over time, but we just want to make sure it's in there. So that's what the grease packed into there, and then you just want to make sure everything goes through, which it should be fine. Yep, the bearing slides right in on the back side, so everything's good there. Any excess grease, go ahead and just get it back inside here once we put that white cap on, just to keep it kind of contained inside this shaft part. Once everything's good, just go ahead and pop that white cap in there, just presses in, and then clean up any residual around the edges, and we should be good right here. So yeah, just make sure everything spins freely. Once we get this thing tested, we'll see how it goes. So the next thing we're going to do, we'll go ahead and change out these capacitors. To do that, you basically just take these two screws off, remove this board, and then pop this little rubber grommet for that off, and then go ahead and desolder these capacitors from the underside. Yeah, once you get to the underside, we'll go ahead and just desolder the two spots for the capacitor. They're on both sides here. The capacitor actually shares one of these with the inductor, the holes or the solder points, which makes it really thick right there, so that's going to be kind of a pain in the ass to desolder. But on the inside one should be pretty easy, so we'll just go ahead and heat it up with the soldering iron and try to remove as much as we can. Once you get that, you break it loose. Go ahead and grab one of the new ones and just put it there. We'll do both of them at once, but you probably want to also verify that it's the exact same numbers that you're getting between the two. I did measure these with my little capacitor tool. That's how I know the size of them or what they're rated at. So this is 952 pico ohms. So right now we'll run the test on the new one just to verify. 1 nanofarad. So basically the same thing, 952, that's within the tolerance. And for these particular sizes, if you want to know the sizes them or the number on them, they're actually JY222M is the number. So that's the number you actually order to get the size that we need here. So we'll go continue getting the rest of this. Now we got everything back in, we'll go ahead and just resolder everything. Pretty easy. Just go ahead, heat up the pad and let the solder melt into it. This big old glob right here, this is actually the wire, the inductor, and the thing all kind of in one spot. So again, kind of let it. Yeah, when you're soldering, you basically just heat up the pad and just let it melt into it and fill everything up. Once those things are done, just go ahead and clip all your leads. And inspect your solder joints, make sure everything's good, and then put it all back together. Go ahead and pull this all back together, line this thing back up, and then put the screws back in. Like I said, I'm not touching the brushes on this one. The brushes still look in good condition. I'll just keep an eye on this. By the time these brushes wear out, this thing will probably leak or have to replace seals again. You gotta make sure you put the wave washer back in. That's important right there. Those things, always forget about the wave washer, so you want to go ahead and put that into there, and we just push this around. I usually just pull the little cable for the brushes back, and then that gets me into there. And then this thing only goes on one direction. There's a notch that you want to look for right here, and then you got to find where you notched it. So I marked that spot, and then goes right into there. And then the hard part now is getting the screws back in. You gotta line the screws with the hole up top. Just blindly looking for the screw to screw into. Usually I just Sharpie marker it, but yeah, once you get the threads, make sure you line it up. So I marked the line there and the thing, and just go ahead and just screw it so everything's tight. Same over here. So the next step is to basically bench test it, see what the amps are that I'm gonna pull out of here. So I'm gonna just have my little rigged thing for my clamp, so I can get the pins in here. Go ahead and clamp the red to the red wire, and then the black, which is negative, to the ground. My power supply is already set to 24 volts, so I'm good there. So it's going. So right now this thing is at. So the amps are dropping. I started at like 2 amps, which I assume because of those new seals, they're really tight. I'm gonna shut it off. I don't want to burn those seals out right now. That thing does heat up. And what you do is when you have it in the water, that water actually acts as a coolant and keeps the shaft and everything cold and cool. But when we run it in here, there's no, it's basically just burning out the rubber. So you want to make sure that thing doesn't run too much on the bench like that. So I'll let it cool down for a little bit and then run it again to see what the numbers are. Run it again. Yeah, right now, those new seals make it start way up there. I'm worried that's gonna cause overcurrent. So after letting it run a little bit and kind of just hitting up, so it's gotten down to 1.1, almost 1.0. So that looks good right there as far as the amps that we should be pulling from this thing. So this thing is a rebuilt motor. Everything's good to go. O-rings and everything for the impeller motor. Again, I got a whole set of these, like 10 or 20 of these from AliExpress, but they all kind of fit perfectly there. As long as you get the right diameter, inner and outer, and thickness, it all fits. So again, get some silicone grease in there. So I went ahead and made all the connections. So all the plugs on here are pretty much only one way to go, but you just make sure all your wire management and routing is good. And then the last 2 plugs go right here, and then right here for the motor and the LED on the actual board. You want to basically prep the board, get all your silicone packs and all that stuff inside there before you put everything in, just to fit it properly. We'll go ahead and tuck a couple more of these silica packs right there. This one I'll put around the actual motor. Go ahead and just kind of fit it all in there, make sure it's everywhere you need to protect it as far as keeping stuff dry, like around the board and everything. Get everything, make sure all the wires are out of the way and nothing's kind of blocking. That's always, want to check that, make sure there's no wires getting jammed and everything like that. So you want to just go ahead and snap it in. This last one you don't want to put in until you get the cord in there. So we got everything set up as far as power and the power supply all connected up. So we'll go ahead and turn it on and see if it goes through its normal routine. So that's a good sign. Everything's rolling. So the drive gear went forward, backwards, We're running the impeller, and it's basically running like it's supposed to right now. So it did stop, so that's not a good sign. So I'll test this in the water to see how it does. Anyways, if you guys found this video useful, give it a thumbs up. If you haven't subscribed to your channel, go ahead and subscribe to your channel. Turn on bell notifications to get notified every time I upload a video. For all these different DIY projects, if I can do it, you guys can do it. I want to thank you for watching, and I'll talk to you guys next time.